Somewhere in East Africa, roughly 300,000 years ago, every single human on Earth had one thing in common: dark skin. Not most humans, not the majority, all of them. Every ancestor you have, no matter where your family is from today, traces back to dark-skinned people living under the African sun. Now, fast forward, humans start walking. Not a short trip, thousands of miles over thousands of years, out of Africa and into completely different environments. Freezing winters, gray skies, months where the sun barely shows up. And somewhere along that journey, something strange starts happening to human skin. It starts changing. Not randomly, precisely, gradually, almost like the human body was solving a math problem it didn't know it was solving. So today, we're going back to where this all started, to answer the question written on every human being alive. Why did human skin become so different? Let's follow the journey. Picture early Homo sapiens in equatorial Africa. Intense sun, essentially year-round, no clouds hiding it for long. In that environment, dark skin wasn't a style choice, it was survival equipment. Skin color comes down to a pigment called melanin, and near the equator, more melanin meant better protection against ultraviolet radiation, the invisible part of sunlight capable of damaging DNA and breaking down a nutrient your body desperately needs called folate, essential for healthy reproduction. So think of early dark skin as the original built-in sunscreen, permanently applied, zero cost, perfectly matched to an environment practically drowning in sunlight all year long. For a huge stretch of early human history, that was simply the human default: one skin tone, one environment, one solution. Then people started leaving. As humans migrated out of Africa, into Europe, into Asia, into places with weaker sunlight, longer winters, and far more clouds, that original sunscreen strategy stopped being helpful. It started becoming a problem. Your skin doesn't just need protection from sunlight, it also needs some sunlight to produce vitamin D, critical for healthy bones and overall function. In low sunlight environments, heavily melanized skin started blocking so much UV that vitamin D production suffered. So now, migrating humans were caught between two survival pressures pulling in opposite directions. Too much sun exposure risked one kind of damage, too little risked another. Evolutionary biologist Nina Jablonski described this as a balancing act, and it's honestly one of the clearest examples in the human body of evolution solving a math problem in real time. Skin color gradually shifted to match exactly how much natural sunlight a population's new environment actually provided. Less intense, less consistent sunlight generation after generation, skin gradually lightened, letting more UV back in. It wasn't a decision, it wasn't overnight, it was thousands of years of the body quietly recalibrating itself to a completely new sky. Here's where the story gets genuinely surprising. For a long time, scientists assumed light skin appeared almost immediately once early humans reached Europe. Ancient DNA says otherwise. In 1903, a roughly 10,000-year-old skeleton was discovered in Cheddar Gorge, England, now famously known as Cheddar Man. When researchers finally sequenced his DNA, the results surprised almost everyone. Dark skin in Britain, thousands of years after humans had already settled there. And Cheddar Man wasn't a rare exception. Broader genetic studies of hundreds of ancient European skeletons found that a majority of early Europeans had dark skin far longer than assumed, with genes for lighter skin not becoming widespread until somewhere between roughly 3,000 and 8,500 years ago, arriving gradually through later waves of migrating farming populations. Picture that. Thousands of years of dark-skinned hunter-gatherers living across a landscape most people today would automatically picture as pale-skinned from the very beginning. History says otherwise. Skin color wasn't a fixed identity handed down from the start. It was still very much in progress. Here's another twist. Light skin didn't evolve once and spread everywhere from a single origin point. It evolved independently multiple times using different genetic variants entirely. European light skin and East Asian light skin are linked to different genetic variants entirely. Evolution essentially solved the same equation, we need more vitamin D in this new environment, separately, more than once, in completely different corners of the migrating human family tree. That's called convergent evolution, and it's a strong reminder that this was never one clean, single storyline. It was several populations on several different journeys, independently arriving at similar solutions to the same environmental problem. Because skin color evolved as a gradual response to sunlight levels, not a small handful of fixed types, biologically it exists on a spectrum, not in neatly separated boxes. Populations living at similar distances from the equator, even on completely different continents with no shared recent ancestry, often independently ended up with strikingly similar skin tones because they were solving the same sunlight math, not because they were closely related. It's one of the more well-established points in modern human biology. Skin color is a real, measurable, and ongoing adaptation, but it doesn't sort neatly into the simple categories people have historically used to describe it. Same species, same starting point, just a very, very long walk in a lot of different directions.